Welcome to Phys 310 Thermodynamics. My name is John Davis, and I have taught this class. This is the third time now, so I'm pretty comfortable with the material, and I'm hoping that can make this pre-recorded lecture series a little bit smoother. So we will have already met once. We'll have met in class before I post these pre-recorded lectures. And so these, I want to just take a moment and talk about what these lectures serve. I'm hoping that you will watch these before class, because we're going to try to use the class time differently. We're going to try to use the class time to discuss questions that you have, but also to work out problems. And we'll use this time and the pre-recorded lectures to actually go over the course content and course material. I'll have discussed the syllabus in class, so we're not going to talk about that right now. But I do want to, I have already talked about the books, but I just want to take another moment and go over the books again. There are two different possible versions of the textbook. This one's called Finn's Thermal Physics by Rex. So that's a redo of this version, which is called Thermal Physics by Finn. Okay, so this is really the original book, and I think this is called the second edition, and this is considered the third edition. Either are fine. Feel free to buy them used on Amazon, whatever you want, but they are actually relatively cheap online. Another possible textbook, which I won't use strictly, but is available, and sometimes I will use some content from, is called Thermal Physics by Schroeder. Of course, all the names of the books are always exactly the same. So these are books about thermal physics. So the first question is, what is a part of this course and what's not a part of this course? So the first thing to think about is thermodynamics is really classical physics. So it's going to involve really macroscopic variables. We're going to think about things like pressure and temperature. We're going to think about volume and density. We aren't going to think about things like the microscopic states that make up quantum mechanics. In fact, one of the coolest things about this class is that it really sets up the next class, I think, beautifully. So this year, this is presumably roughly your third year in physics. You'll be taking quantum mechanics either this semester or next. And next semester, you'll be taking statistical mechanics. So what you can really see, if you think about it carefully, is that quantum mechanics is really the microscopic that lies on this end, and thermal physics is really the macroscopic that lies on this end, and statistical mechanics is going to be the bridge between them. So hopefully you see that come out in your next course. So what that means is we're going to talk about things like pressure, temperature, volume, number of particles, or really moles, but it's not going to talk about things like entropy. Right? So we will include entropy in our physics. We will think about entropy quite a bit. Helmholtz free energies and Gibbs free energies, all these kinds of things, but we won't discuss where they come from. We won't discuss the microscopic origins, for example, of entropy. That is really reserved for next course, Phys 311, StatMax. StatMac. Okay, so one question I have is what kind of math are we going to be seeing? So we'll be seeing a lot of partial derivatives. So in some ways, this is the course where you'll learn partial derivatives, and you will learn them by use. Okay, so just as a reminder, so this is lecture 1, just an introduction. We're going to have things, for example, like heat capacity. Okay, so we're going to have a heat capacity, which is going to be the partial derivative of the energy U with respect to T at constant volume. Right? So this is a partial derivative taken with constant volume, but you could have had the heat capacity at constant pressure, which is partial U, partial T at constant pressure, constant P. Okay, so we're going to have a lot of things like that. So that's going to be the kind of the basic of the math in this course. What else are we going to discuss? We're going to actually get to the laws of thermodynamics. So there's going to be, the third law, the first, second, and third law of thermodynamics, but we're also going to actually have the 0th law in the next lecture. And we're going to importantly discuss the concepts of equilibrium. So equilibrium is one of the most important concepts in the beginning ideas of thermodynamics. So we're going to discuss what happens when you wait long enough, right? So we're going to say, what happens when you wait long enough? So this is actually going to have, so thermodynamics is going to have a lot of applications. So we're going to have applications to engines. We're going to do a lot about refrigeration. So despite being a low temperature physicist, I think I always spell refrigeration incorrectly. So that brings actually a good point. So this is a course about thermal physics and about, in fact, a lot about how to make things cold. So engines in some ways make things hot, do work. And one of the products that we want to do often is refrigeration. So I'm actually a low temperature physicist. The goal of my lab and a lot of the aspects of my lab is to get things cold. And when we get things cold, we can see new physics. Now, a lot of that physics is quantum physics, but also, this has applications to phase transitions, right? So we're going to discuss phase transitions in this class. You'll see a lot of what I like to think about is getting things cold and what happens when they get cold. But also, we're going to see a lot of applications to your real and everyday life. How does the heater work in your house, and how can we make it more efficient? Is it efficient, right? The efficiency of an engine or the efficiency of a refrigerator, an air conditioner. We're going to think about how to make the various fun ways of making the refrigerator in your house more efficient. But we're also going to think about things like phase transitions. One example where we talk about ice skating in hockey, right? And so there's applicability to a wide range of physics in your everyday life, because this really is a course on the macroscopic variables, right? Those things that you actually experience in your life. Unlike quantum mechanics, which you rarely see in your everyday life. We're going to talk about pressure. We're going to talk about climbing Everest, right? And so we're going to get to that in just a couple of lectures. How do you think about the pressure on the top of Everest? So there's a lot of applicability and a lot of things that are going to happen in this course. So hopefully you're enjoying the pre-recorded lectures so far. And I'm going to go on to stop here. And I'm going to start the second video in just a second, where we go on to lecture 2 and start talking about some of the basic concepts of thermal physics. So basic concepts of thermal physics coming up next.